Assalamualaikum and salam sejahtera to all of you. Okay, these are the continuity from the previous chapter, okay, on carbohydrate. And then I want to recap again. Carbohydrate have three types of saccharides, yeah, whereby we call as monosaccharides, disaccharides, and also polysaccharides. There are also another saccharides which called as oligosaccharides. Okay, in terms of the number, monosaccharides refer to one saccharides. Okay, and then disaccharides refer to two saccharides. Okay, polysaccharides normally from 10 and more. Okay, and then oligosaccharides normally 3 saccharides until 9 saccharides. But as I mentioned earlier, oligosaccharides are rarely found in the plant. Okay, so let's go to the polysaccharides. Okay, so normally polysaccharides is actually a complex carbohydrates whereby you can get it from the potato, sweet potato, from the tuber, orange sweet potato, purple sweet potato, okay, and also that's example, or maybe tapioca, okay. So that's a complex, what we call saccharides. Complex means you cannot get the carbohydrate directly from the polysaccharides compared to monosaccharides. For example, monosaccharides, you just eat the fruit, then you can get the fructose, but not in the polysaccharides form. Okay, and normally polysaccharides, okay, we can get it from the starch, okay, fiber, and also glycogen. Okay, first we look at the starch. Okay, normally starch you can find it in the plant, yeah, reserve of plant, food reserve of plant, whereby if let's say you look at the orange sweet potato, okay, the sweet potato itself we call as food reserve of the plant, yeah, and then it is actually a two different polysaccharides whereby it is mixed together, okay, amylose and also amylopectin. Okay, and then normally the percentage of amylopectin inside the starch are 80% and 20% is amylose. And then grain, for example, okay, it is actually starch. Okay, any kind of grain. And then you can see the grain normally we can see it from the granules form. Yeah, for example, cereal, that's a grain. Yeah. And then next, these are the pictures that I show you in the class, okay, whereby when the heated, when the we call polysaccharides before heated, you can see, okay, the structure is quite different compared to when heated. The granules only, you can see the granules in few forms, yeah. But then when you heat, you put some heat on the starch granules, then it become we call spread, yeah, okay. And then inside the polysaccharides, there's also glycogen. Okay, normally glycogen we can find it in animals, okay. And then as I mentioned earlier to you, even human, human also has a glycogen. How? Okay, whereby we can have the glycogen if let's say we have a lot of what we call glucose. Okay, we have a lot of glucose, and then the glucose will convert. Okay, in our body, okay, the system of the body will convert the glucose, the excessive of glucose, to the glycogen. Okay, if let's say the glycogen a lot has excessive amount in our body, then the glycogen will be converted to lipid or fat in our body. Okay, and then let's continue on the glycogen. it is actually reserve of carbohydrate in animal. Reserve means simpanan, yeah, whereby means berlebihan lah, yeah. Okay, and then normally animals will store the glycogen in their liver and muscle. In our muscle, yeah, in our muscle, if you have your muscle, a big muscle means you have a lot of glycogen. But if let's say our body need it, okay, or animals, chicken for example, need it will convert it into glucose. Okay. Once you got glucose, then it will provide energy to our body. Okay. In terms of fiber, okay, for the polysaccharides, you can get it from the vegetables and fruit. Okay, let's look at the examples of the fiber. Okay, in terms of properties. Okay, vegetable gums, okay, are also under fiber, and then it act as plant hydrocolloid. Okay, normally plant hydrocolloid used to combine ingredients. Okay, emulsify the ingredients or mix well the ingredients. Okay, for example, carrageenan, seaweed extract. Okay, or maybe uh, you can see the what we call seaweed. Okay, if you grind it and you boil it, okay, you put with maybe with flour, it will become thick liquid, yeah. And then you need, of course, you need to put some water, right? Okay, and then you boil, of course it will thicken. Okay, and then there's also guar gum, okay, plant seed, and the other one xanthan gum. Normally for xanthan gum, it become as a stabilizer and also improve the quality of the food. Okay, so hopefully you can Google the picture or the image of this kind of gum. Okay, and then look at the next slides. Okay, pectin. Okay, it is actually a complex mixture of polysaccharides. Okay, whereby normally pectin comes from the plant inside the fruits actually. Inside the fruits and also root vegetable. Okay, pectin, okay, important for the gelling agent. And also when you want to make a jam, you need to use the pectin. Okay, and then 60%, 65% of the sugar needed, okay, to have a gel formation for the jam making, for example, yeah. Okay, and then for the pectin, okay, fruit with lower pH, okay, will have the pectin. Okay, but if let's say what we call the fruit with what we call less acidic, okay, you need to add with acid. Okay, and then the lower the pH and its setting means when you have the lower pH, of course there's a problem or there's a different content of the pectin. Okay, for example, you have the mango, raw, what we call unripened mango yang belum masak. Okay, so pectin inside the unripened what we call mango normally less, okay, compared to the ripened mango. Okay, ripened mango means what we call masak, yeah. And then because of what? Mango, ripened mango normally has a lot of pectin, okay, compared to unripened mango. And then if let's say the fruits, okay, or the mango over ripened, okay, of course there's a process, right, from the unripened, okay, ripened, and also over ripened, kan. So if let's say your mango overripe, overripe or over-ripen, then the content of the pectin actually a lot, and then if let's say the mango becomes overripe, the pectin already broken down, rosak, yeah. Okay, and then it will what we call make the fruits, okay, unsatisfactory in terms of quality. So pectin will broken down as fruit ripens, okay, but okay, if let's say a lot of pectin, okay, broken down, okay, and then with we call rosak in terms of the pectin content, okay, your fruit will be low quality, yeah. Okay, next we look at the fiber. It is a non-caloric, but it can act as fat replacer. It is high solubility, okay, pH stable, and ability to become a gelling agent. Okay, for the fiber, it is also can make as a food additive. Okay, whereby it will thicken. Okay, it is also reflects to the gum, yeah. Smooth texture and water binders. Okay, for the gum and also pectin, it become as an emulsifier and increase the viscosity of the ingredient. Okay, these are the examples of gum in food preparation. For example, salad dressing. Okay, ice cream to increase the mouthfeel, the chewing gums for the flavor binders, yeah, and also jams. Gums are used as a thickener and also binders for the ingredients used. Okay, so next we will continue with properties of sugar.